Hello everyone, this is Karanveer Singh. I will be taking the topic of heat exchanger, which is the part of heat and mass transfer. With respect to gate, this topic is very important. You can always expect a single question of 2 marks or more questions from this topic. And moreover, this topic is easy. So let's begin. Heat exchanger. What are heat exchanger? Heat exchangers are steady flow adiabatic open system. Let me write it. Steady flow adiabatic open system. What is this? Let me explain this with the help of a diagram. Let this be a heat exchanger. This is a fluid which is at high temperature, and this is a fluid which is at low temperature. Since this is at low temperature, so it is cold fluid, and this is at high temperature, so it is hot fluid. Hot fluid, cold fluid. Since hot fluid is at high temperature than cold fluid, so there would be a heat transfer from hot to cold. Let it be dq. dq is the heat that is transferred from hot to cold. We are writing a word adiabatic. Since we are writing adiabatic, so the heat that is lost by hot fluid, it will be taken by cold fluid. It will, no part of that heat would be lost to environment, because we are having an adiabatic system. Since the system is adiabatic, we can write Q is equal to 0 from the basics of thermodynamics. And since the system is steady flow, steady means the mass is flowing continuously. Steady flow adiabatic open system, we can deduce that W is also equal to 0. This is from the basic of thermodynamics. So now writing the first law of thermodynamics for this heat exchanger. Let us write this steady flow energy equation. Q minus W is equal to change in enthalpy plus change in kinetic energy plus change in potential energy. Since the system is adiabatic, Q is 0, work done is also 0. Kinetic energy. Since the system that is heat exchanger is not moving, so we can write change in kinetic energy is also 0. The system that is heat exchanger is not moving above or below, so we can write change in potential energy is also equal to 0. So we get delta H is equal to 0. That is, the change in enthalpy of the heat exchanger is 0. From here we can write delta H of hot fluid plus delta H of cold fluid is equal to 0. We can write delta H of hot is equal to delta H of cold. This is the rate of decrease of enthalpy of hot fluid. This is rate of increase of enthalpy of cold fluid. These are equal in terms of magnitude. Now in thermodynamics, we have done delta H can be written as m dot Cp delta T. This is from thermodynamics. You must have done in that. So writing this equation in terms of this, we can write m dot H means hot, Cph T hot inlet minus T hot exit is equal to m dot C. C is cold, CTC TC exit minus TC inlet. This equation is very important. We will be using this equation in the analysis of heat exchangers. I will repeat it again. M dot H is mass flow rate of hot fluid. Cph is specific heat of hot fluid. This is the temperature, inlet temperature of hot fluid, exit temperature of the hot fluid, mass flow rate of cold fluid, and this is specific heat of cold fluid, exit temperature of cold fluid, and this is inlet temperature of cold fluid. Please note it.